Okay, let's do this. It's question number 11 to 20 for SCS-C02 reviewer. This is for AWS Security Specialty Certification. So, yep. Wait. So, for question number 11, you will be given a company that wants to receive email notification about critical findings in AWS Security Hub. The company does not have an existing architecture. You are required a solution that detects critical finding from AWS Security Hub, sends email notification when such finding occur, and can be implemented from the scratch since no existing architecture is in place. So the question goes, a company wants to receive an email notification about critical finding in AWS Security Hub, and the company does not have an existing architecture um, that support this functionality. Which solution will meet the requirement? A. Create a Lambda function to identify critical security hub findings. Create an Amazon simple notification services SNS topic as the target of Lambda function. Subscribe an email endpoint to the SNS topic to receive published message. Letter B. Create an Amazon Kinesis Firehose delivery. Integrate the delivery streams with Amazon Event Bridge. Create an bridge rule that has a filter to detect the critical security findings and configure the delivery stream to send the findings on email address. Letter C. Create an event bridge rule to detect the critical security hub findings. Create an Amazon simple notification service topic as the target of the event bridge, and subscribe an email endpoint to the SNS. Letter D. Create an event bridge rule to detect critical security hub findings. Create an Amazon simple email services topic as a target of the event bridge rule. Use the Amazon SCS API to format the message. Choose an email address to be the recipient of the message. So the correct answer is letter C. Create an event bridge rule to detect critical security hub findings and use an SNS topic as a target of the event bridge rule. Subscribe an email endpoint to the SNS topic to receive published message. Why YC is the best solution. Event bridge can natively detect and filter security hub findings, including critical severity. SNS is designed for fan out notification, including email. The setup is simple, serverless, and cost-effective. Perfect for company without existing infrastructure. Email subscription to SNS is straightforward, doesn't require custom formatting or API call. While the others fall short, it adds unnecessary complexity with Lambda, which isn't needed just to route findings to SNS. Kinesis Firehose is overkill and not designed for email delivery. These misuse SES. There's no such thing as SES topic. We have SNS topic, but SES doesn't have SES topic for direct event bridge integration, and it's more complex than SNS. So the correct answer is Amazon Event Bridge and simple notification service. For the question number 12, you were given a new business entity and AWS account are set up in South Korea. The workload is deployed in Up Northeast 2 region. The workload consists of the auto-scaling group of Amazon EC2 instances. All workload in this region must retain system and application log for 7 years, and the company currently has no existing logging solution. A security engineer must ensure no logging data is lost during auto-scaling. During scaling activities, and logs are retained for exactly 7 years. A solution captures long reliability from EC2 instances even during scale-in, scale-out events. Stores log in durable services such as CloudWatch log in Amazon S3. Enforces a 7-year retention policy on those logs. and use IAM to grant necessary permission, is automated and scalable across auto-scaling group. I think S3 is not mentioned in the question, and yeah, it doesn't. Yeah, there's no requirement for S3 here. An international company has established new business entity in South Korea. The company has established a new AWS account to contain the workload for South Korean region. The company has set up the workload in new account up Northeast 2 region. The workload consists of 3 auto-scaling Amazon EC2 instances. All workload that operate in the region must keep system lag and application lag for 7 years. Security engineer must implement a solution to ensure that no lagging data is lost from each instance during scaling activity. The solution also must keep the logs for only the required period of 7 years. Which combination of steps should the security engineer take to meet those requirements? You need to choose 3. Letter A, ensure that CloudWatch agent is installed in EC2 instances that the auto-scaling group launch. Generate CloudWatch agent configuration file to forward the required logs to Amazon CloudWatch log. Set the log retention for desired log group for 7 years. Attach IAM role to launch configuration. For launch template that the auto-scaling group uses, configure the role to provide necessary permission. Attach an IAM role to launch configuration or launch template that the auto-scaling group uses. Configure the role to provide the necessary permission to forward logs to Amazon S3. Ensure the log forwarding application installed on all EC2 instances that the auto-scaling group launch. Configure the log forwarding application to periodically bundle the logs and forward the logs to Amazon S3. Configure Amazon S3 lifecycle policy on the target S3 to expire object after 7 years. So there's no mention of S3 in the question. And answers D and F mentions about S3. Letter C and D is the same, except that it's using CloudWatch. So A, B, C are using CloudWatch, and we're not required to use S3. So the correct answer is A, B, C. So install CloudWatch agent and forward logs to CloudWatch log. Set the log retention for 7 years in the CloudWatch logs. Attach an IAM role with permission to forward logs to CloudWatch log. Instances need an IAM role to push logs to CloudWatch log securely and automatically. The following options are incorrect. Forwarding directly to S3 is not necessary. Doesn't guarantee no loss during scaling. Custom log forwarding app is more complex and not required when CloudWatch log handle this natively. Life cycle policy is only needed if logs are stored in S3, which they are not in this setup. So for question number 13, you will be given this policy. If you look at the policy, it's an EC2. It's a describe instance, stop instances, and terminate. The resources it's for everybody, right? Or resources for all EC2. All EC2. Oh, no, all resources, not just EC2. All the resources can describe EC2 stop instance and terminate instance. So the current policy has no condition allows anyone with permission to perform the listed EC2 action required. For the required, the security engineer must modify the policy so that multi-factor is required before IAM user can access this API, and the session must retain valid for only 2 hours. So security engineer is designing an IAM policy to protect AWS API operation. The policy must enforce multi-factor authentication for IAM user to access certain services in the AWS production account. Each session must remain valid for only 2 hours. So the current version of IAM policy is as follows. So, yep, we already saw that. Allow everyone to. So we are required to have an MFA and valid only for 2 hours. So the correct answer is multi-factor auth present is true, which is A, and numeric less than multi-factor age of 7,200. There's no max session duration for multi-factor. So the correct answer is A and C. So, yep. So this is an easy question. So you just need a multi-factor auto present true for B and multi-factor at age of 7,200, and there's no max session duration. The question number 13 or 14 is, you are given a company uses AWS organization and as production workload, security engineers tasked with designing solution. The company wants to proactively monitor for suspicious behavior across all production account, automate remediation of incidents, send notification to SNS when critical findings are detected, and centralize all security incident logs in dedicated accounts. So it's almost similar to the previous questions. No, we don't have we have an SNS, right? We're going to monitor the production workload. It's not an easy to, there's no mention of what the workload is. Required a multi-account security solution that detects suspicious behavior across account. Automates remediation. Okay, we'll automate the remediation by event bridge and lambda, and publish notification to SNS. Aggregate logs finding into central logging account. Why event bridge? Because event bridge can trigger lambda, right? A company uses AWS organization as production workload across multiple AWS accounts. Security engineering needs to design a solution that will proactively monitor suspicious behavior across all accounts that contains production workload. The solution must automate remediation of incident across production accounts. The solution also must publish notification to Amazon SNS topic when critical security finding is detected. In addition, the solution must send all security incident log to a dedicated account, which solution meet this requirement. So we have an AWS organization doesn't. Okay. We have multiple accounts and we're using AWS organization. That was what is required. So letter A, activate Amazon Guard Duty in each production account. In dedicated logging account, aggregate all Guard Duty logs from each production account. Remediate the incident by configuring Guard Duty to direct invoke AWS Lambda. Configure the Lambda function to also publish notification to SNS topic. Letter B, activate AWS Security Hub in each production and dedicated logging account. Aggregate all Security Hub findings from each production account. Remediate the incident by using AWS config and AWS System Manager, and then configure the System Manager to also publish notification to SNS topic. Letter C is aggregate Amazon Guard Duty in its production account. Dedicated logging account, aggregate all Guard Duty logs from each production account. Remediate incident by using Amazon Event Bridge to invoke a custom AWS Lambda function from Guard Duty findings and configure the Lambda function to also publish notification to SNS topic. Letter D is to activate the Security Hub in each production account. In dedicated logging account, aggregate all Security Hub findings from each production account. Remediate incident by using Amazon Event Bridge to invoke a custom AWS Lambda function from Security Hub findings and configure Lambda function to publish to notification to the SNS topic. So answers letters A and C uses Guard Duty, and B and D uses Security Hub, right? And then, well, we need to use what? We need to use, I think the correct answer is C. Amazon Guard Duty in dedicated logging account aggregate all guard duty logs from each. Remediate the incident by using Amazon Event Bridge and invoke a custom AWS Lambda. So either we use Security Hub or Guard Duty, but I think we need to use the Guard Duty, or I don't know which one are we going to use. Is it Security Hub or it's a Guard Duty. So yeah, we know from previous question that we are going to use an SNS, and what can trigger Lambda is, let's not make it long, it's an event bridge, so letter C is the correct answer. Yeah. So the best solution that meets all the requirements for proactive monitoring, automated remediation, and SNS notification and centralized logging is Amazon Guard Duty in each account, and in dedicated logging account aggregate all Guard Duty log from each production account and remediate the incident by using Amazon Event Bridge to invoke a custom AWS Lambda function from Guard Duty findings and configure the Lambda function to publish notification to the SNS topic. Here's why this is the most complete solution. Guard Duty provides continuous threat detection and is purpose-built for identifying suspicious behavior across AWS account. Event Bridge allows you to automate remediation by triggering Lambda function based on Guard Duty findings. Lambda can handle both remediation logic and publish alert to SNS to critical findings. Centralized logging is achieved by configuring Guard Duty to send findings to dedicated security account, which is best practice in multiple accounts. Why others fall short? Letter A, Guard Duty cannot directly invoke Lambda, so you need an event bridge to do that. Security Hub is a central aggregator, not a threat detection engine. AWS config and system manager are useful but not ideal for real-time remediation. And letter D is wrong because Security Hub findings are often aggregated from other sources like Guard Duty, so it's not the primary detection tool. Okay, so Security Hub is wrong because it's an aggregate or not a detection tool. So 2, B, and A is wrong, and Guard Duty is the correct answer, and it uses the event bridge to trigger Lambda, right? For question number 15, the company is designing a multi-account structure for its development team. It uses AWS organization for centralized account management. It uses AWS IAM Identity Center, AWS SSO for federated access. The company wants to restrict developers to only specific AWS region and restrict each AWS to only specific AWS services. You require a solution that enforces region level and service level access control, apply across multiple accounts, has the least operational overhead, and centralized, scalable, and easy to manage. So we have a multi-account structure for its development team. It uses AWS organization and Identity Center SSO. The company wants to restrict developers on the specific AWS region and restrict each AWS account to only specific AWS services. This is only for the developers, right? So enforce region level and service level access control applies across multiple account, has least operational overhead. So it's an IAM that we're going to use. Okay, the answer is C. Anyway, a company is designing multi-account structure for its development team. The company is using AWS organization and IAM identity center single sign-on. The company must implement a solution so that the development team can use only specific AWS region so that each AWS account allows access to only specific AWS services. Which solution will meet this requirement with the least operational overhead? I am centered to set up service-like roles with IAM policy statement that includes condition, resource, and not action element to allow access to only regions that are needed. Deactivate AWS STS security token services in region that developers are not allowed to use. Create service control policy that includes condition, resource, and not action element to allow access to only regions and services that are needed. For each AWS account, create tailored identity-based policy for IAM Identity Center. Use the statement that includes condition, resource, and not action element and allow access to only regions and services that are needed. The correct answer is C, as we saw already. Because STS is you need to rotate that. It's more complex. IAM policy statement that includes IAM identity center set up a service like role, but that's only for IAM. It's not for the service. You need a service control policy, right? So SCP is the correct answer. Service control policy applies on organizational or OE level, allowing centralized control across multiple accounts. SCP do not require per account or per user configuration, reducing administrative burden. You can use conditional resources and not action to precisely restrict access to specific services and region. SCP overrides identity-based policy, ensuring consistent enforcement regardless of what IAM policy exists in individual account. IAM center are account specific and require manual setup per account, increasing operational overhead. Deactivating STS is not scalable and doesn't prevent access to services in those regions if credentials are already available. Creating tailored identity-based policy per account is labor-intensive and harder to maintain across multiple accounts. For question number 16, you are given a company which is developing an e-commerce application uses EC2 RDS. EC2 and RDS for compliance reason, data must be secure in transit and secure at rest. So the company wants a solution that minimizes operational overhead and minimizes cost. Require a solution that encrypts data in transit, encrypts data at rest, and uses managed services built in AWS to reduce manual setup and maintenance. Avoid expensive or complex option like the third-party certificate or hardware module unless absolutely necessary. So question number 16, a company is developing an e-commerce application. The application uses Amazon EC2 instances and Amazon RDS, which is, so you have a database on RDS. MySQL, for compliance reason, data must be secure in transit and at rest. Company needs a solution that minimizes operational overhead and minimizes cost. Which solution meets this requirement? A, use a TLS certificate from AWS Certificate Manager with application load balancer. Deploy self-signed certificate on EC2 instances. Ensure that the database client software uses a TLS connection to Amazon RDS. Ensure encryption of RDS DB instances. Enable encryption on Amazon Elastic Block Store volumes that support EC2 instances. B, use a third-party TLS certificate with an application load balancer. Install the same certificate on EC2. Ensure that the database client software use the TLS connection to Amazon RDS and use Amazon Secret Manager for client-side encryption of the application data. Use AWS Cloud HSM to generate TLS certificate for EC2 instances. Install the TLS certificate on the EC2 instances. Ensure that the database client software uses TLS connection to Amazon RDS. Use encryption key from Cloud HSM for client-side encryption of application data, and D, use Amazon Cloud Front with AWS WAP, send HTTP connection to the origin EC2 instance, ensure that the database client uses TLS connection to Amazon RDS, use AWS key management, client-side encryption, or application data before the data is stored in the RDS. So letter B is wrong, letter A is the correct answer. It's you use the certificate manager because you're managing an encryption certificate, and it can be used from ACM, and not, you don't store the certificate to HSM, and Cloud Front is for WAP only, for web-based application only. So the correct answer is A, security in transit of TLS certificate from AWS Certificate Manager with an application load balancer provide secure HTTPS connection with automated renewal, reducing operational overhead. Self-signed certificate on EC2 instances are acceptable for internal traffic if cost is concerned. TLS connection to Amazon RDS ensures secure communication between the application and the database. So it's secure at rest because RDS encryption, Amazon RDS encryption, secure database storage with AWS managed key, and Amazon Elastic Block Store encryption protects the EC2 instance volume also during AWS managed key. Operational overhead, since it's local, ACM automates certificate provisioning and renewal, unlike third-party or cloud HSM option. So AWS managed encryption for RDS and EBS is easy to enable and maintain. Cost efficient. ACM is free for use with ALB. Some-signed certificate on EC to avoid extra costs, and no need for cloud HSM third-party certificate, which is expensive and more complex. Third-party certificate increases cost and operational overhead, and you don't need to use it. Use a secret manager for the secret because it's not for the certificate. You use ACM for the certificate, and secret is for keeping passwords and stuff, and it's not used for certificate management. Cloud HSM is costly and more complex. It's overkill for basic compliance need. CloudFront and WAP are for content delivery and for security filtering, not internal app encryption. Sending HTTP to AC2 violates the in-transit encryption requirement. Question number 17, you are given a company designing an e-commerce application. The application will run on EC2 instances in auto-scaling group behind the ALB. And you'll be using an RDS database instance for its database. Internet connectivity is required for HTTP and HTTPS traffic to the application. The application must communicate with internal payment provider. So almost similar to the first question, except that it accepts traffic only from pre-configured allow IP address. The company must ensure uninterrupted communication with the payment provider. You are required a solution that restricts internet exposure to only ALB. Ensures that EC2 instances can reach external payment provider using static IP. Keep the RDS DB instances private. Ensures scalability without breaking the outbound communication. Uses best practice for subnet placement. So you are to choose 3. Security engineers work in a company to design an e-commerce application. The application will run on Amazon EC2 instances that runs an auto-scaling group behind an application load balancer. The application will use Amazon RDS DB instances for its database. The only required connectivity from the internet is HTTP and HTTPS traffic to the application. The application must communicate with external payment provider that allows traffic only from a pre-configured allowed list of IP address. The company must ensure that the communication with the external payment provider are not interrupted as the environment scale. Which combination of action should the security engineer recommend To meet this requirement, choose 3. Letter A, deploy a NAT gateway in each private subnet for every availability zone that is in use. Place the DB instance in public subnet. Place the DB instance in private subnet for letter C. Configure the auto-scaling group to place the EC2 instance in public subnet. Letter E, configure auto-scaling group and place the EC2 instances in private subnet. Deploy the ALB in private subnet. So, the EC2 and the DB should be in the private subnet. So, that should be C and E. And for you to able to reach the payment system, you will need to use a NAT gateway. So, there should be A, C, and E. Okay. So, basically, you just have to place the EC2 instance on private subnet, so it's not available in the internet for other users, and RDS is also in the private subnet. And then you deploy the NAT gateways per availability zone, and you need to allow listed outbound IP address for the payment provider. The usual design is to create a NAT gateway in each AZ zone with its own elastic IP, so the outbound traffic for the instance that the AEC uses is predictable EIP, and you don't get across AEC's single point of failure. Note, in AWS, a NAT gateway is placed in public subnet with an elastic IP, and the private subnet routes table point to it. And the exam option is aiming for the NAT gateway per AZ or availability zone idea. So, D and D is wrong because you're exposing your database and EC2 to the internet, which is not acceptable. ALB in private subnet will not communicate to your payment system. And you should put the ALB in the public subnet so it can receive HTTP and HTTPS. Assign elastic IP to each NAT gateway and give those IP to the payment provider's allow list. Use security groups and route table to restrict between ALB, app, and app RDS only. Question number 18. Given your company uses multiple cloud formation stack to deploy a suite of applications, some team members encounter permission during stack deployment. Other team members can deploy stack successfully. All team members assume that the role with permission tailored to the job responsibility. All team members have permission to operate on stack, but deployment fail inconsistently. Required a solution to ensure consistent stack deployment for all team members is secure following least privilege and role delegation best practice. Resolve permission error likely related to cloud formation, needing to assume roles to perform action. Support role-based access and service role delegation during stack execution. So we're talking about cloud formation. So company uses several cloud formation stack to handle deployment of suite application. The leader of the company application deployment team notices that the stack deployment failed with permission error when some team members try to deploy the stack. However, other team members can deploy the stack successfully. The team members access the account by assuming a role that has specific set of permissions that are necessary for the job responsibility of the team member. All team members have permission to perform operation on the stack. Which combination of steps will ensure consistent deployment of the stack most securely? You need to choose 3. So create a service role that has composite principal that contain each service that needs to be that needs the necessary permission. Configure the role to allow assume role action. B. Create a service that has a cloud formation Amazon.com, Amazon AWS.com as a service principal. Cloud formation at Amazon AWS.com as service principal. Configure the role to allow Amazon assume role action. For each required set of permission, add separate policy, which is right? To the role to allow those permission at the arm of each cloud formation stack in the resource field of each policy. For each required set of permission, add a separate policy to the role. Allow those permission at the arm of each service that needs permission in the resource field corresponding policy. Update each stack to use the service role. And letter F, add a policy to each member role to allow pass role action and set the policy resource field to the ARN. So we need an assume role and we need to have that pass role. So that should be F. And letter B, because we don't want to create a composite principal. And another so should be D. For each required set of permission, add a separate policy to the role to allow those permission at the arm of each service that need permission in the resource field of the corresponding policy. Okay. B and C is almost the same except that, yeah, B, no, D and C is needed. So we need F, we need B, and then we need D. Oh, yeah, it's B, E, E update stack to use the service role. Okay, okay, what we need is E instead. Yeah, we don't need a composite. Create a service role with CloudFormation app, Amazon.com as the service principal. Configure the role to allow STS assume role. This allows the CloudFormation to assume the role and perform action on behalf of the stack. Update each stack to use service role. This ensures that all stack operations are executed using the same trusted role, avoiding permission inconsistencies among team members. Add a policy to each member role to allow IAM pass role action. Set the policy resource field to earn of the service role. This allows the developer to pass the service role to CloudFormation during stack creation or updates. What other options are incorrect? A composite role overcomplicates the trust relationship. CloudFormation only needs to be the principal. Permission scope to stack are not scalable or necessary. CloudFormation need permission to act on resources, not stack metadata. Permission scope to service ARN misapplies the resource tailed services like EC2 or S3 don't have ARNs in this context. Oh, that's why this is wrong. Question number 19. So we're given a company's lift and shift migration from on-prem to AWS. And we're talking about VMs will be migrated to EC2 instances. The company now wants to replace EC2 hosted components with managed AWS services. And the first transition is to move from EC2 based load balancer software to Elastic Load Balancer. Security engineers responsible for ensuring centralized and searchable log for auditing. Ensure metrics are generated to show which hyper are in use. Require a solution that centralize ELB logs such as S3 CloudWatch log. Make log searchable via Athena or CloudWatch log console. Extract hyper usage metrics from logs and publish those metrics to Amazon CloudWatch. Use managed service to reduce operational overhead. So here's the question. A company uses a lift and shift approach to migrate from its on-prem data center to the AWS Cloud. The company migrated on-prem VM to Amazon EC2 instances. Now the company wants to replace some components that are running on EC2 instances with managed AWS services that provide similar functionality. Initially, the company will transition from load balancer software that runs EC2 instances to AWS Elastic Load Balancer. A security engineer must ensure that after this transition, all load balancer logs are centralized and searchable for auditing. The security engineer must also ensure that metrics are generated to show which ciphers are in use. Which solution will meet this requirement? Create an Amazon CloudWatch log groups, configure the load balancer to send logs to the log group, use CloudWatch logs console to search log, create CloudWatch logs, filter the logs to the required metrics. B. Create an Amazon S3, configure the load balancer to send logs to S3 bucket, use Athena to search the log that are in the S3, and then creates an Amazon CloudWatch logs filter on the S3 files for the required metrics. Create an Amazon S3 bucket and then configure the load balancer to send log to S3 bucket. Use Amazon Athena to search log that are in the S3 bucket. Create Athena queries for the required metrics. Publish the metrics to Amazon CloudWatch. Create the Amazon CloudWatch logs log group. Configure the load balancer to send log to the log group. Use the AWS Management Console to search the log. Create an Amazon Athena query for the required metrics. Publish the metrics to Amazon CloudWatch. So we'll be migrating from an on-prem VM to an EC2 ALB or EC2 Elastic Load Balancer. And the security engineer must ensure that after this transition, all load balancer log are centralized. So might be using, for ALB, I think it can send logs to S3. So that's why we have S3 on this selection. So we have two S3 which is in B and C. We're going to use an Amazon S3 bucket, configure the load balancer to send log to S3, which is correct. Use Amazon Athena to search log that are in S3, and then create an Amazon CloudWatch Amazon Athena queries for each required metrics, which is most likely C. Right. Because if you just filter, you're not going to create the metrics. You need an Athena query to create the metrics. Great. Create an Amazon S3, configure the load balancer to send log to S3 bucket. Use Amazon Athena to search the log that are in S3 bucket. Create Athena queries for the required metrics. Publish the metrics to the CloudWatch. C is best because centralized logging, ELB access log can be stored into Amazon S3, which is scalable and cost-effective. Searchable log, for searchable log, you need to use the Amazon Athena to run SQL queries directly on S3 stored log. Cipher metrics, you can write Athena queries to extract cipher usage from ELB logs and publish the metrics to CloudWatch using custom script or schedule query. CloudWatch log is not a native destination for ELB. Access log ELB logs go to S3, not CloudWatch logs. It's just for EC2, right? CloudWatch logs filters cannot be applied directly to S3 files. Athena is needed to query S3 logs. Athena cannot query CloudWatch logs directly. It queries S3. This setup is invalid. That's why C is correct, right? Question number 20, last question for this set. Given the company uses AWS organization and single region management account is named Management 01, AWS config is enabled in all accounts, security 01. So we have two account, Management 01 and Security 01. Security 01 is the delegated administrator for AWS config. An aggregator in Security 01 collects compliance status from all accounts. Each account admin can maintain their own AWS config rule. A security engineer must automatically deploy 10 AWS config rule on all existing and future accounts. Ensure AWS config is activated automatically during account creation. So a solution is required that automates deployment of AWS config rules across all account, works for existing and future account in the organization. Activate AWS config during account onboarding. Uses secure, scalable, and centralized deployment mechanism. Honors and delegate administrator model. Security O1 and management account authority. So we have two. Now we're going to manage an AWS organization in a single region. A company uses AWS organization to manage its multiple account AWS environment in a single AWS region. The organization management account is named Management O1. The company has turned AWS config in all accounts in the organization. The company has designated an account that named Security O1 as a delegated administrator for AWS config. All account reports to the compliance status for each account rules. So the AWS delegated administrator account by using AWS config aggregator. Each account administrator can configure and manage the account's own AWS config rule to handle each account unique compliance requirement. Security engineer needs to implement a solution to automatically deploy 10 AWS config rules to all existing and future account. The organization To all account in the organization, the solution must turn AWS config automatically during account creation. Which combination of steps will meet this requirement? You need to choose two. Now we need a conformance pack. Create an AWS Cloud formation template that contains 10 required AWS config rule. Deploy the template using Cloud formation stack set in Security O1 account. B. Create a conformance pack that contains 10 required AWS config rule. Deploy the conformance pack from the Security O1 account. Create a conformance pack that contains 10 AWS. Deploy the conformance pack from Management O1. In the create an AWS Cloud formation template that will activate AWS config. Deploy the template using Cloud formation stack set in Security O1. And E. Create an AWS formation template that will activate AWS config. Deploy the template by using Cloud formation stack set in the Management O1 account. I think the correct answer is B, and we need a conformance pack. But who is going to deploy it? It's going to be Security O1, and we need a Cloud formation template that will activate the config, the AWS config, which will be that's wrong. Should be Management O1, right? Either way, we just need conformance pack and we need a Cloud formation template. So conformance pack will be deployed by it's B and E. So we'll get one correct. To meet the requirements of automatically deploying AWS config rule to existing and future accounts and activating AWS config during account creation, here's the most secure, scalable solution. Letter B conformance pack that contains AWS config rule. Deploy the conformance pack from the Security O1, which is correct. Since Security O1 is the delegated administrator for the AWS config, it can centrally deploy conformance pack across all the organization. Conformance pack are the recommended way to bundle and deploy multiple AWS config rules consistently. This ensures that all accounts, current and future, receive the same compliant rules. Create an AWS Cloud formation template that will activate AWS config. Deploy the template by using Cloud formation stack set in the Management O1 account. The Management account has the authority to deploy stack set with auto deployment to the new account in the organization. This ensures that AWS config is automatically turned on when new accounts are created. The stack set can include the necessary resource to initialize AWS config. While the other option falls short, deployment of Security O1 using stack set on auto deploy future accounts, only Management account can do that. See, while conformance pack can be deployed from Management account, Security O1 is the delegated admin. So the correct answer, so it's the correct origin for AWS config rule deployment. Some issues as a security cannot auto deploy stack set to a new account. So that's all, and let's put questions 11 and 20. 11 to 20.